Today we explore the King's rule, a beautiful symmetry property of definite integrals. This is King's rule. It states that for any continuous function f defined on the interval from a to b, the integral of f of x is exactly equal to the integral of f of a plus b minus x over the very same interval. In other words, reflecting the input of the function about the midpoint of a and b does not change the value of the integral. That is why it is also called the reflecting rule. Let's see why this is true. Let's begin by setting up our coordinate axes. Here is the graph of f of x, defined over the interval from a to b, with the enclosed area shaded in green. Now let's create a copy of this same curve, shifted to the right by a plus b. This gives us the function f of x minus a plus b, defined between 2a plus b and a plus 2b, with its own shaded area in blue. Let's draw dashed guidelines connecting the matching points on both curves, and mark the vertical line at x equals a plus b, which will act as our mirror. Finally, let's label the key points on the x-axis, along with the two functions, f of x on the left, and f of x minus a plus b on the right. Since the two shaded areas are equal, let's take the right area and reflect it about the mirror line, x equals a plus b. Let's remove the original curve on the left and its shaded area, since we no longer need them. Now let's reflect the right curve about the mirror line, x equals a plus b. This gives us the graph of f of a plus b minus x. And here is the shaded area under the reflected curve, between a and b dot, which is exactly 𝑗 because it originally come from copy of f of x. Let's bring back our guidelines, and label the reflected curve as f of a plus b minus x, alongside the original shifted curve, f of x minus a plus b. From the graph, it is clear that the integral of f of x, from a to b, equals the integral of f of a plus b minus x, from a to b. Because the areas under both curves are exactly the same.